trying to switch on my camera as well, right?
Hello.
And start the presentation. Thank you very much, Mate, for this presentation. It was really nice, and I'm really excited to see that the autonomous functions are ready now. So let's get back together and try it together with Skybrush. um, okay, let me share my screen. Uh, can you see my presentation now?
Yes, I can.
Okay, great. So the last talk from Matai was mostly a hardware presentation, and I will in my talk I will talk about software and not hardware mostly, but it's also related to the Crazyflies. So I'm Gábor Vásárhelyi from Collmot Robotics, and I would like to introduce you to our uh, brand new in like our systems called Skybrush, which is brand new in the way that we have open sourced it in uh, a couple of weeks. So I hope many of you will be able to enjoy the great possibilities of that. A little bit about my and our group's background. So uh, our company is named Collmot, which stands for Collective Motion, and this is because we started research on collective motion like more than 13 years ago now, together with the whole crew who is working at Collmot now. And the main topic we were analyzing was swarming and flocking of animals, and we were trying to understand how what are the building blocks of collective motion, how, for example, these birds, what you can see on the screen, uh, make decisions. We put like GPS devices on them and collected the track logs, and then so what kind of hierarchy is there for the decisions, if someone is making a left turn, how the others are following, and who are the leaders, who are not the leaders, and throughout gathering information from the animals, of like from pigeons and from rats and from ants and many other animal systems. We had a really a very exhaustive uh, research lab working on understanding collective motion. We like one of our goals was to replicate this behavior and create swarms of drones that are autonomous as well. And throughout the years, basically we focused on two directions for autonomous drones. If you can see the videos on the left side, you see the flocking behavior, which means that drones are trying to synchronize their motion and fly together autonomously in a way that nobody is controlling them. They are just logged into like virtual GPS fence, and they define among themselves when to turn and how to turn, the same way as birds do. And on the right side, you see traffic, which is coordinated motion of many drones in the same airspace, but without actual synchronization of the motion. So these are basically the two main building blocks that we have been working on, and I'm uh, quite confident. But if you know of someone else, please let me know. But I'm quite confident that we are kind of the world record holder for both of these things in terms of the number of drones involved in these really autonomous operations. And so with our team, we investigated these drone swarming systems, and as Matai with the flapping drones, we also got a lot of very good media feedback, and so we founded Collmot Robotics in like 2015, so really many years back, with the goal to commercialize somehow this know-how of drone swarms. And of course, the first systems where drones, where many drones were needed together, was drone shows, and all the other industrial projects are still lagging behind this, but drone shows are really quite advanced by now. And so the first service we were providing with our drone swarms was drone shows, and throughout these research projects and the drone shows, we also started to develop many software solutions for the drones and for the ground stations to be able to control these systems like in an automatized and smart way. So yeah, this is just really some of the media attention. We are actually not among the biggest drone show companies. We are really kind of researchers, and we are focusing on very special and innovative effects. So, for example, we created these light paintings and some holographic effects with a smoke curtain on the air and like projecting some laser light from drones to drones in the air, and also we were the first to create like a fireworks launch from the drone. So we are trying to play around with that, but we also provide standard drone shows as well with large fleets of drones. And so Skybrush became our like throughout the years became our own system for controlling the drone shows from the design phase to the execution. And finally we decided to try to not only sell it but to share it and share it with the community for many of you to use, not only for shows but also for other projects where many drones are needed to cooperate in a way and needed to be controlled. And it's a general it's a very modular software system. The main concept is built upon the line of drone shows, but it can be used for any kind of drones form application. So we have Skybrush Studio, which is a design and validation platform for creating missions and creating shows easily. We have another module called Skybrush Viewer for visualization of shows and sharing them with clients. We have Skybrush Live, which is the actual ground control station software, such as the Crazyflie client, but it's optimized for drone fleets and drone swarms. We have Skybrush Sidekick, which is not really useful for indoor shows or indoor swarms with Crazyflie. It's mostly for outdoor settings where you really need like a secondary channel for controlling the drones to have some kind of a safety fallback. And then this is an independent radio channel operating on that. And then Skybrush Server is kind of a backend that is responsible for all the communication and the control for the drones, to be able to integrate many drone types together, for example, into a common framework. And of course, we need some kind of firmware that is running on the drones, and we have developed compatibility with two main open source branches. One is the Crazyflie ecosystem, and the other one, this is for indoors, and the other one is the Ardocopter. Probably most of you are also familiar with that. This is mostly for outdoor show drones. So we have like modified versions of the firmware for both of these code bases, and that then you can upload that to the drones and then be compatible with Skybrush. So a little bit more details about each of these modules. So the studio part, the drone show design part, is we have many different tools, but the most advanced tool right now that is for the public is integrated into Blender, which is another open source animation software, another piece of open source code. And basically Skybrush Studio is a plugin in Blender. It's available on GitHub if you are interested. With that you can create, you can have a storyboard with different formations that where you define each formation one after another in a parametric way, that you say that, okay, this formation starts at frame 0 and ends at frame 1000, the next starts at frame 2000, etc. And then you can import formations and dynamic stuff very modularly, and then you can create the transitions between these formations automatically. So if you imagine a setting when you have like hundreds of drones. It's very useful if you don't have to take care of all these mappings of trajectories, like if you have one formation and the other, which drone should go to which position from the first formation to the next. So this is all done automatically, and you can concentrate on really the beauty part of your show, the creative part. You can add parametric light effects to the whole scene, select drones, and change colors dynamically. And I will not explain too much, but you can give it a try. And what is really important that when you are an artist and you are working with a show designer, it's good if you don't have to take care of the technical limitations. And for this to have like an easy checking system, we have a real-time validation system integrated into this plugin. So it gives you warnings all the time when some of the drones are too close to each other, like below a safety distance, or the altitude of them is too high, or their speed is too high, etc. So in the design phase, you get visual feedback on this, and then it's easy to correct the things. So the next stage of creating a drone show is when you are ready with the show. It's good if you can share it with your friends first, and then your client, or with your colleagues, and try to get like a clean visual understanding of the whole show from different directions and along with music, etc. So for this, there is Skybrush Viewer. It's also an open source code. There are two main aspects of Skybrush Viewer. So it's basically an interactive real-time rendered 3D view. You can select for Crazyflie the indoor setup and setting, and for the Ardocopter the outdoor, and you have a different scenery, and day and night settings are also possible. You can set in the show file that you are creating with Studio. You can have like different cues in the storyboard, and then these are visible on the timeline to help you understand where you are in the show. You can define preset cameras and then change the view accordingly. So if you have set up a show to be visible from a specific point of view, then you can check these points very easily with Skybrush Viewer. The whole show can be, of course, synchronized to music, and it's very important that this whole thing can be run in a browser, so you are able to share the shows with a client only with sending them a link, and then they can check it on their own browser easily. And of course, and also Viewer contains another validation layer. So once the whole show is ready, you can get the timeline of all these important parameters, like what is the horizontal velocity, the vertical velocity profile, the proximity between the drones, and basically the altitude. These are the four most important things that have some kind of limitations when you are designing any kind of drone trajectory. So it's very useful if you can get an overview of this, if these thresholds are broken or not. Okay, so when you are ready and you have a show file, we provide a very nice show format for that is very condensed and human readable as well, but contains all the information you need for a drone show. Then you can use Skybrush Live, which is the ground control station for the drones. It's fully compatible with the Crazyflie system as well, and there are some nice features in Skybrush Live. So you get these most obvious views. You have a list of the drones, and you can see all their parameters, or get some kind of condensed view to see all the drones at once. And for outdoors, a map view is probably more important than for indoors, but for indoors it's also useful to see the positions, and you can also like add all kinds of geometric objects in a GeoJSON layer. So if you want to define an indoor setup, or you have any kind of tiles for your indoor settings, then you can import that as well. So you can recreate your indoor setup as well as the background. When you load the drone show, you based on the positions of the drones, it's very like you just put down your drones and set up your basic field, and then the system automatically assigns the drones to the trajectory, so you don't have to like care about this mapping that which drone will fly where. It's all automatic. There are all kinds of like very nice smart status widgets with summarizing the most important information for you about warnings and errors and critical states and communication signals, and etc. So for outdoor settings, also about the weather, but for indoor, some of these things are limited, but there are some things that are useful there as well. You can define geofence also for the Crazyflie drones for indoors. It can be very useful if you want to protect your audience from the drones leaving a certain virtual space. And there is also a lot of smart pre-flight checking integrated into this system, which are new in the fleet level operation. So when you have an individual drone, you are probably used to the general setup, how a drone should be initialized. But when you have many drones, there are a lot more things to think about and to check when you start. For example, if drones are not switched on the takeoff area. So if you have like 3 drones and you want them to start from 3 positions, and you switch 2 of the drones, then they will look identical, but it will cause trouble, because then their trajectories will cross to get back to their good position. So this is checked, for example, in Skybrush, or any kind of like altitude differences. You can get like nice statistics automatically if everybody is at the same like altitude, and then it gives you more information about your environment in some kind of a distributed sensing way. So you can utilize this and get some kind of pre-flight checking that is not available with a single drone. So we are trying to use this smartly. Okay, and once you are ready with Skybrush Live, and actually there is one more component behind Skybrush Live that is responsible for the communication, that is server, but okay, sorry. So Sidekick is like a secondary channel. It's a reduced ground control station software with basic functionality to be able to put the drones in different modes, bring them home or land them or disarm them in the air as an independent kill switch that is needed many times from the flight authorities. And it works on an independent channel, uses like an alternative radio channel. This is for outdoor drones, not for Crazyflie, but I don't know, for Crazyflie this is not very important. But you can also control the light of the drones and give them some correction signals, for example, for GPS reception. So anyhow, getting back to the backend, so behind Skybrush Live and Skybrush Sidekick, there is a Skybrush server running all the time. So this is a very modular code running in Python that is handling the asynchronous communication and control with all the drones that are connected to it. So and it also handles all the accessories attached to the system. So if you can even get like different kinds of drones, small ones and big ones, Ardocopter drones or Crazyflie drones, any other drones using Mavlink protocol in one setup. All of them can communicate with their own communication channel to the Skybrush server, and then the server is translating all the messages coming from the drone into a standardized protocol, and then communicate with the front end, the Skybrush Live, and on the live system, you don't even need to know what kind of drones you have, because the communication is already standardized. So this is a very, very nice modular system, modular architecture. It's very easy to extend to new drone types. So I don't know if what will be needed, Matej, for your drone to integrate it with Skybrush, but probably this can be done in a short time now that it can do autonomous flight, and it can also run locally next to your drones, or you can create a VPN network, and then you can have a server with remote operation, and then you can have front end anywhere on the network, so you can really control your drones remotely from anywhere around the globe. And Skybrush server is also open source. And so the last piece of code that you need for running Skybrush is the firmware. So we have a customized fork for Crazyflie and Ardocopter as well. Both of them are also on GitHub, and both of them we are trying to follow the latest upstream release. So we are trying to be up to date with all the code that the communities are developing. Our own section of the code is always just kind of a modular new show mode into which you can bring the drone with Skybrush Live easily with a click, and then the drone is following the show trajectory, and so it builds on the inner position and attitude controllers, and just using this show file to follow a predefined trajectory. So it's quite modular, and therefore it's easy to upgrade it to the new code if that arrives. So what the show mode does is basically just a very precise spatial temporal trajectory following. So in the shows, you don't even, like when you're following a trajectory, you don't only need to follow it in the space, but also have to be at a specific point at a specific time to be synchronized with all the drones. So this is this constraint makes it a little bit more difficult, but this is resolved in our code. And the other aspect is the light control, which is also implemented in real time. So basically, when you design a show file, it will be a one single compressed file, and Skybrush Live and Skybrush Server splits it up into small portions that are needed for each drone. And then one drone gets like one piece of code that contains the trajectory and the light, and then it just runs that and will be synchronous with the others. And some of the pre-flight checking is also implemented on the firmware level for Skybrush. And so this is the basic modular system of Skybrush, and specifically for Crazyflie users, we have some, or I would like to introduce some more extras for those who want to develop the system or get into the details. So one nice thing we have designed is a messaging protocol, this standard interface between the Skybrush server and the front ends I was talking about. So it's basically a JSON-based, JSON message-based protocol, very human readable and easy to understand, and it's optimized for fleet level operations. So for example, you have this UAV test command, then you define the IDs, which drones you want to perform, and the component will be motored, and then this kind of message will say that, okay, on drone 1, 17, and 31, run the motor test. And if you send this message from the front end to the server, then the server will translate this message into the Crazyflie language or the Ardocopter language or any other language that is needed, and then run the test. it's also, this whole messaging protocol also supports the asynchronous operation, because if you have many drones and uncertain and not reliable communication channels, then this is a very important aspect, that you have to handle everything in an asynchronous way. It covers most of the drone use cases, and it's easy to extend if you have any new requests on it. And I hope it's well documented, but if not, then give us some feedback and we'll help. So another interesting stuff is what we needed to implement for this asynchronous operation for Skybrush and the swarm level operation is kind of a re-implementation of the Crazyflie Python library with asynchronous functions based on Trio and async IO. It's not standard. I mean, it's not fully compatible with the standard official Crazyflie API, but it has this huge advantage that it's optimized for the fleet handling. So we are really we really hope that this will spread in the community, and you will find this useful. And Skybrush server is using this as well to communicate with the Crazyflie drones. The third thing I would like to mention is that so far I was mostly talking about drone shows, but since we started this whole swarming from the research point of view, and we are doing research ourselves, and we believe that in the future many swarming applications will appear in other industries as well, not only in the drone shows. We really designed the Skybrush suite to be modular and to be very extendable in terms of new applications. And so one of these things that we just now started to get ready with, but it's already in Skybrush server, is to have some kind of a general mission implementation in it. So missions are identified as asynchronous tasks that are running in the background in Skybrush server. You can initiate a mission from a front end or manually or in a synchronized way, and then you can define your custom running functions for each drone and define what the server should tell the drone to do during different states of the mission. So it's kind of in an early release state, but we hope that this will enable Skybrush server to be used in many applications that are not even show related. And so basically what I wanted to show is that Skybrush is really an open source ecosystem. We have open source firmware, open source modules, open source communication protocols, and mission and show file formats that we think are really well defined and that are really using our more than a decade-long knowledge about swarming. It's the whole thing is transparently and well documented. We have a Discord channel where we can build our community and answer all kinds of technical questions that are arising, and we have this server that is extendable. And I really hope that with the Crazyflie system and all the research and scientific users of Crazyflie, this will give like a new push to this to Skybrush to use it together with Crazyflie for scientific purposes. So we are really like trying to tell you to try this Skybrush system and contribute in any way that is convenient for you. Of course, we have professional versions of the software as well. So we keep some of the modules in a professional version, and we provide like VIP support for those who want to run their business without problems and need help with that. So you can buy some of the components as well from Skybrush if you are running a professional business, but you can also play around with it in an open source context. And finally, what I would like to talk a little bit about how the Crazyflie system was tested, or how far we got with with integrating Crazyflie with Skybrush. So basically, we have a fleet of 10 Crazyflie 2.1 standard drones, and we tried the Skybrush with them, and at like the main feedbacks what we can give is that it's working really nicely. Like it's compatible, and the firmware is there, and it's ready, and you can play around with that. We feel that the power to thrust ratio is a little bit low for that, especially when you have the some kind of positioning deck and the LED, like both the lighting and the positioning on the drone. So in these cases, if you want the drone to fly at high speeds or want to sync at high speed and then stop, then the power will not be enough for the drone. And also, because of the very small size of this drone, the flight time that is usually suitable for many scientific experiments in a show setting, this could be enhanced. So it's more convenient to play around with the drone, and it would be nice to have more flight time on it, but it works. We also tested the Bolt system with a client of ours who built 9 drones, a little bit bigger drones based on the Bolt system and based on the instructions that we got from the Bitcraze fellows. I don't remember exactly, but the total takeoff weight was around, I think it's around 100 grams. A very nice feature that it's running on lithium-ion batteries. I think for this small drone size, this is really the future instead of lithium polymer. And it had a very good power to thrust ratio, much better stability due to that than the small drone. Of course, it's also like brushless motor, so the speed of the motor can change much quicker, so the stability gets better with that, and the flight time is also much better. So this is a really promising direction, and really hope that sooner or later there will be new Crazyflie prototypes that are a bit bigger and bit stronger, and will be really suitable for shows. And like regarding the positioning systems, from the Skybrush side, it doesn't matter what kind of positioning system the Crazyflie is using, because it just uses the position that the Crazyflie is communicating. But we tested with the local positioning system with UVB with 4 anchors. We are lucky that we are still connected to the university, so we get access to very large testing rooms. So we actually tested the UVB at a room with 20 by 14 by 6 meters, which is, I think it's quite large, and it's actually a beautiful room. And that's the one that Matej showed as well in the presentation. And yeah, the accuracy of the UVB is lower than, for example, the lighthouse. It's around like 10 to 20 centimeters, but it's stable in such a large area with 8 anchors. And the only thing you have to be careful about is to have your drone inside the convex hull of the 8 anchors, because if you fly outside, then it will be unstable. But otherwise, it's working nicely. And the other positioning system we have been testing so far was the lighthouse with 2 base stations. There, the positioning accuracy is much better, only a few centimeters, but the range is also smaller, so we couldn't fly like further than 4 or 5 meters from the base stations. And the drawback is that you need this visual line of sight between the base stations and the drone. So for a show context, this can be disrupting, because if you have, for example, dancers in the scene or any kind of object, then it can be a problem. And also you have to be careful about the light conditions, but otherwise it's the positioning accuracy and also at the price, what you can get, like compared to, for example, an OptiTrack system, I think it's really remarkable. So I don't know, I'm asking the Bitcraze fellows as well, like how this multi-base lighthouse system is at the current state. But if you can enlarge the space used by the drones based on the lighthouse system, then this could be a very good thing as well. And this is just one project, just to mention a use case as well. It was performed by choreographer Nina Kov in Sweden last year, and with these 9-bolt-based drones that were uh, assembled by Nina, and based on the instructions we got from Bitcraze. It used the lighthouse base stations and the Skybrush together, and they performed like 5 or 6 shows perfectly without any problems, like with laser lights and smoke and all kind of nice effects. So it was a successful show already with using Skybrush and Crazyflie drones. And I also created finally a list of some things for Christmas from the Bitcraze team for the community. I mean, some things that I think that could be useful if these were working or these were better. So it would be really nice to have some kind of a bigger drone or stronger drone with more flight time. It could be based on the Bolt or could be based on the small Crazyflie with brushless motors or whatsoever. So we had many discussions about it. We will see where this can go. More flight time is definitely a must for a drone show. So anybody who who is in this field and entertainment feels that like you cannot have like a flight time that is just enough for a show. You need reserves there to be able to be stable. And regarding the UVB, there is this new module, the DVM 3000. I don't know if you have heard about it, but it promises much better accurate positioning accuracy. So it's an interesting thing when this will be integrated into the UVB system. Although we haven't tested the UVB with more than 8 anchors, so this is something that we need to do later on to be able to have much larger areas, and also with the lighthouse with more than 2 stations. What I feel is a little bit lacking from the Crazyflie system is some kind of nice and nicely working sensor fusion based from one aspect. If we compare the Crazyflie system with the Ardocopter system, then the Ardocopter was growing on or sucking the milk of the noisy GPS system in a way, and so it got mature in an environment where there is a lot of stochasticity, like a lot of wind and GPS noise, etc. So I think the inner extended Kalman filter of the and sensor fusion of the Ardocopter system is really doing well, and opposite to that, the Crazyflie system, when it started, the OptiTrack and Vicon and all these very accurate positioning systems were already available indoors. So there is a little bit less effort done or put into the system being very stable when the sensors are more noisy. So I think this could be enhanced. But I really know that it takes a lot of programming effort and testing effort. But this is something that I think if the UVB is the direction, this needs to be solved, and if the lighthouse is the direction, then it needs to be resolved that then many base stations work together in a way that the drones are not jumping when one base station is off or on, because right now this is the case a little bit. And of course, what we wish is to have many users and developers in our joint community where the Crazyflie and the Skybrush systems are working together. So this was more or less what I wanted to say, and I just summarized for the presentation some of the most important links where you can check us out and download the code. So thank you very much. And ready for questions.
Yeah, thank you very much, Gabor. Thank you for the feedback too. We worked on multiple base stations. We have implemented the stuff that is working. It's not. It's still on the test phase, but we've published it. It's. I can find you somewhere the link on the blog post about it. Yes, but meanwhile, if you have any questions or comment for Gabor, please ask them in the chat or by raising your hand through the Google thingy option.
See that there are also some questions already in the message.
Yeah, there's a mini Kiyoshi that said the Skybrush software looks great. I suppose that outdoor drones by Bolt and GNSS RTK might be good starting vehicle to test drive Skybrush.
It's interesting. I don't know how Bolt and Arctic, like outdoor and Bolt, are brought together, but let's try it. I mean, I forgot to mention that at the end of the last slide, uh, or from the homepage, like we really have a Discord channel for all these technical integration issues. So anybody who wishes to try Skybrush, you are welcome to join our Discord channel, and we can discuss all these details there, and we can help with the integration. Our goal is to have Skybrush compatible with as many drone types as possible, of course.
Yeah, Thomas actually provided the Discord link. Thank you, Thomas.
About motion capture integration, yeah, we just realized that we have another nice research group in Hungary who are using Crazyflie and using OptiTrack. So I will really target them to try our system there. But yeah, that could be a good feedback. But basically, I think Skybrush is really not dependent on the positioning, the actual positioning system. So if standard Crazyflie is working in some kind of positioning system, then it should be compatible with Skybrush as well.
Yeah, just to add my 2 cents to it, basically, I think all that needs to be done in order to integrate an external of the positioning system like the quality system or OptiTrack is that basically we need to have a background process which constantly streams the detected positions from the standard OptiTrack or quality client to the drones. This can be run inside the Skybrush server or as a completely independent process. But since the show itself is controlled from the drone, and there is absolutely no need for any kind of connection between the ground station and the drones during the show, it should be relatively easy, I would say.
Yeah, thanks, Thomas. I know that there's Mehmet from Qualisys that is listening intently on that. Is there any questions?
I think Mehmet is asking something, but I cannot hear. Maybe you are muted.
Yes. No, we can't hear you. Sorry.
There we go. Okay, I think I saw.
Yeah.
Yeah. All right. I have too many microphones connected to this computer. Sorry for that. I do have a question. It was me who typed in the question about mocap, but I was wondering, with the indoor positioning systems that you've been using, what kind of sort of limitations that you encounter with regard to, for example, how close you can bring the drones, how dense can you make the swarm, or how many, like, is it difficult to set up the different IDs and things? Because one of the things I'm noticing is that at Qualisys we have an active marker deck, which BitCraze is actually selling. So we developed it together, and that active marker deck solves a lot of problems that we used to have before with passive markers, such as the difficulty of making unique marker configurations for every drone in a large swarm, which then get confused by the mocap system if they're not unique enough. And it's difficult to accomplish in a small volume like the Crazyflie. So with the systems that you've been using, especially indoors, what were some of like the limitations that you're experiencing that limit you from having many drones or doing certain kinds of maneuvers?
So I will try to start the answer, and then I will pass it to Tamás. He will probably have some notes as well. So there are, from one aspect, there are physical limitations. So because these drones are very small and they are creating turbulent air around themselves, you cannot bring them very close to each other because of the turbulence they are creating. They are flying quite well next to each other as far as I experienced, but if you fly one above the other, I think you need to have a much larger distance, let's say half meter, 1 meter, or something like that. But if your positioning system is good enough, then you can bring the Crazyflie drones very close to each other horizontally. Regarding the IDs and things like that, so with the UVB, I think this is quite easy, and once you have set up your anchors and numbered them in the firmware, and you numbered your drones as well with their IDs, then this is all automatic in Skybrush, and you will not get confused at all. But and regarding the lighthouse, it's also very, like, in terms of setting up the system, I think this is the easiest. So it's really easy to just click on setup, and then the whole thing will automatically calibrate itself, and it's working quite nicely. So the setup time is the best for the lighthouse, and then it's worse for the UVB, and I think it's the slowest for all these optical camera-based systems, where you need the most time for setting up, but after that their positioning will be better. So
Cool. May I ask one more thing, or are we short
Yeah.
on time?
No.
or
Go ahead.
maybe Tamás, anything else you would like to add?
Maybe just one more thing. So basically, with the UVB system, what we have experienced is that our flight zone is 12 times 18 times 6 meters. But to be honest, the last 2 meters near the convex hull of the flight zone, the drone tends to get sometimes unstable in that region. So the space that we would actually use for a show is actually smaller than this 18 times 12 times the 6 meters with the UVB. It might be the case that we haven't been setting it up very exactly, because we didn't have any like laser rangefinders to measure the distances. So it might be the case that this can be improved, but still with the UVB system, I would say that the usable range of the UVB system, if you place the nodes so far from each other, is somewhat less than what you would expect. That's all basically. And with the lighthouse system, I mean, if you have two base stations, then the original setup method is that where you just put down the drone and then tell the system to calibrate, and it's all done in half a second. That's great. But I don't know how it will look like when you have 3 or 4 or more base stations, because that process might be more complex, and then it might come closer in terms of complexity to the UVB system. We'll see. That's all.
Yeah, you had one last question, Mehmet. You're muted again. Sorry.
Sorry for that. I don't use this app usually. I'm usually on Zoom. I'm not used to it. Anyway, is it only the case that you're able to do like recorded or pre-planned, pre-designed kind of shows, or are there any like interactive capabilities? So, for example, if I'm tracked and I walk into the drones, they part and let me through, or something like that. Is that something that you can integrate into Skybrush, or is it do I have to find another way of handling that kind of input, for example, to the system, real-time control?
So on our own drones, the outdoor drones, we have that capability because we designed those drones to be able to do swarming. So we can do all kinds of interactive things outdoors. On the Crazyflie, this is not implemented, and since with Skybrush, we usually work in a way that there is no constant communication from the base station to the drones, not to disturb the drone and rely on maybe unstable communication. So if we want to keep ourselves to this, then you need to implement something on the drone, or you have this drawback that you can implement also on the server side some kind of thing if you have all the positioning data available in the server, but then if the communication is not good enough, then you will be in trouble. But anyhow, on the Crazyflie, this interactivity is not implemented yet. We had some inquiries about that, but nothing was too strong enough so far to make us implement it. But
I'm doing it if you want to talk later. That's exactly what I'm working on these days.
yeah, it's very interesting. Yeah.
Yes, we have two more questions. I know Jörg Philip has raised his hand, but I'll take first the question that appeared in the chat to have still talking about positioning system. So Pyeongjong Kim said your conclusion is that current Crazyflie plus indoor positioning system are not suitable for the drone light shows. Then is there a hardware option to perform drone light shows with Skybrush in indoors environments?
So Tomasz is answering on the message part, and I would like to add that we didn't want to discourage everyone or anyone from using Skybrush or Crazyflie. I think that indoor drone show is really like an emerging field, and there is no good solutions, no perfect solutions yet. The Crazyflie, we are working with Crazyflie because we found that this is the most mature systems of all that we know of. So and it, like, you can already do a lot of things with the small Crazyflies in a drone show settings as well. But as Tomasz is also saying, there are compromises still. So you need to stick to the smaller flight time, and you need to stick to lower dynamical ranges perhaps. But you, like, we had shows with the Crazyflies already. And some of the users had shows with them. But as Tomasz is saying, the bolt-based drones that are a little bit larger and a little bit stronger, I think they are a really good candidate. So we really believe that this is a good line we are on, and it will lead to something really, really, really good in the future.
Yeah, thank you. Do you want? Maybe it's time for the question from Jörg Philip Frohner that raised his hand.
Thank you. Gábor, just one or two short questions. First of all, you mentioned that on your own drone you have the interactive ability. So does that go through Skybrush? And do you have kind of a separate module where you have the interactivity on your drone? And the second question would be, in your tests with Crazyflie for indoor drone shows, the performance with you controlling this 10-piece swarm, are you content with that, given a proper positioning system which you already elaborated on?
So the first question, on the outdoor drones, we have a companion computer that is on board and running a full stack of swarm control capabilities, and it's communicating on board with the Arducopter code. So we are developing that for a long time, and it's really a unique system, and that's a system with which we are doing these really large scale autonomous things. So, but that's really a lot of extra code that is on board. So that's why it's not on Crazyflie, because for that you need either much more code space or some extra computer that is, for these small drones, is not available so far. The second question, I couldn't get exactly that. Am I satisfied with the positioning accuracy, or sorry, could you repeat?
No, with the whole system performance in terms of Skybrush controlling the 10-piece Crazyflie swarm, in terms of really the outcome, because you're obviously a very experienced drone show operator, and were you content? I mean, you already touched upon the implications of the positioning systems, but the whole system in itself, you said the Crazyflie is the most mature drone. You are a very experienced drone show software, no pun intended. However, the whole system performance you were happy with.
So actually, we are never satisfied with anything. So we are never satisfied with our own system. We are developing it all the time. If the GPS positioning gets better, then we introduce the RTK. If the RTK modules, there is a new one, then we replace them to have better accuracy, etc. So the same process is going on with indoors as well. So the basic functionalities are there and working, and there is always the technological advances that make these systems better and better. But it's kind of a never-ending story. You are either always satisfied or never satisfied, but nothing in between, I think.
Thank you.
Just wanted to chime in with one more thing regarding the outdoor system. So right now, this whole swarming and collective collision avoidance thing, it runs on a companion computer. I have long-term plans to actually integrate it into the quadcopter firmware such that you wouldn't need the companion computer. But this is like something that's always on the horizon, but I never have time to do it. Mostly because our drones in outdoors, they create an ad hoc wireless network between them, and they use that to share their positions with each other. And this is different from this classical router-based networks, and I'm not sure whether we can actually make the Wi-Fi modules, these cheap Wi-Fi modules that you typically use with quadcopter-based drones to create this mesh network between them. So this is something that I would need to investigate, and it takes several weeks on its own. But I do have long-term plans for getting rid of that companion computer and just building the whole swarming logic into quadcopter itself.
But I think in an indoor setting, for example, for Crazyflie, this is a different, because usually the space is more restricted. So having a simple Wi-Fi network could be enough, and the router can be strong enough to support all the drones in a room. And it's very different from an outdoor setting where you can go like 1 kilometer away, and then if you are dependent on a router with another drone that is like 5 meters next to you, then it's a problem. So there in the outdoor setting, you need the ad hoc network for interactivity, and for the indoor setting, you don't necessarily need that.
Yeah. I know that Christopher has been dying to say something. Christopher, you have the floor.
Yes, I just wanted to add some more information to first the loco positioning system. There is actually support for more than eight anchors in TDA3. It's not well tested, but I mean, what could possibly go wrong? It's there, but I think it needs to be tested a bit. I have done some simple tests, but it should work. And for the lighthouse, I wrote a new geometry estimation thingy to support more than two base stations, and that is available. I put the link in the chat, and hopefully that is also improving at least on the jumpiness when base stations are occluded, because I think it's mainly caused by a poor geometry estimation, pretty much. And I mean, this estimation is a little bit more complex. You put the Crazyflie in the origin, and then you put it in a few more places on the floor to define the coordinate system, and then you walk around in the space and wave your Crazyflie around to collect data, and then I use that to estimate the base station geometry. So it's more similar to maybe a mocap system setup.
And does it work, your estimation system, with more than 2 base stations as well, or it's
it does. You can, I mean, it supports up to 16, but you can pretty much you can have 4 base stations sort of visible in one point. Then if you have five, they're gonna interfere too much, so then you pretty much don't get any data at all. But that's a feature of the lighthouse. But you can have, for instance, you can set up base stations that are not overlapping, so then you can have more than 4.
Yeah, thank you. There is time for questions if you want, or to Gábor, or even to us at BitCraze. No? Perfect. Well, so that's it. I think I want to thank you, everyone, for coming and listening to these 2 amazing talks. Thank you, Gabor. Thank you, Matei, for those presentations. As I mentioned, everything has been recorded and will be put on the our YouTube channel sometime at the end of the week, let's say. But yeah, thank you very much. Have a nice evening, afternoon, morning, wherever you are. And we hope we see you for the next Minibam that's yet to be determined.